And in this booth, we can track people with sub-millimeter accuracy. We are faster than everybody that can receive our tracking information. We can track with moving lights, we can track with robotic cameras, we can track with spatial audio, so sound reinforcement, so that the sound coming out of speakers follows around out of his mouth as he walks around, which is the holy grail for the audio guys. And we can also track and have proven and done shows now where we can manipulate video content and we can track screens moving around with projectors projecting on screens. We did NERCA in London in January, where there were 4 screens on stage being pulled around by dancers, 1 projector, 1 green hippo. We tracked the screens, and we tracked them in a 50 by 30 foot area, and we were doing XY tracking on screens and rotation. And what's happening there is one projector is projecting 4 separate video images onto these screens, and they were playing, dancing in front and in and outside of each other. If you have time afterwards, I can show you the video of that all happening. Last night, if any of you were at the KOI Awards, we were tracking the sword and the lovely hostess that came in, and as she was spinning the sword around, we were real-time live tracking that with lights. So it didn't matter where she went, she was covered with lights while she had that sword. And it all worked flawlessly, and I relaxed at that point. So we've gone to a higher speed, higher resolution, faster system, and it's almost ready to go out in the marketplace. And as you can see, Justin is wearing one of our new beacons. In fact, he's got 2 or 3 on.
Yeah, I have 2 on me right now. So I can easily switch from tracking one object to both objects simultaneously.
You're also looking at the glue that Blacktrax works on, and we've fashioned it very much like lighting consoles, so that the lighting guys are going to be able to walk into this and understand it instantly. And it does some very clever things, and it hands over lights from us to the lighting and back again. While we're tracking for lighting, we're only tracking pan and tilt. So what I'm saying is, while somebody is being tracked, we only orient pan and tilt, zoom and iris of the light. Everything else is done through the console as per normal. So we take control of that light, and then we hand it back afterwards.
So what's the data stream?
Keep time manually red-white.
From around here to the ArtNet output.
Yeah, we're extremely fast. Our problem is the lights aren't. So we're working with a lot of manufacturers to get the light speeds up. And it's only actually the starting speed of the light that's the issue. Once the light's moving, tracking is not a problem.
No, what I meant was that you're interrupting the whole DMX stream, and you're not.
We're actually downstream merging. And we're only squirting in what we need into it, so there's no interruption in the stream.
But you're not slowing it down in order that you can feed your data in.
We're using a failover node. So we have a direct feed from the console into our system, and then we sync our clock with the console's clock. So as soon as we get data from the console with that DMX stream, either over ArtNet or raw DMX, we say, okay, we got the data. We have about at that point we have data already coming in from the 10 milliseconds from here, so that's buffering. We're looking slightly ahead. So by the time the data comes in, we say, all right, the data's through, inject that, and immediately send it out based on that console clock. So we're not adding any extra delays to that,
so
other than...
I understand where you're coming from. The communication between the console and the lights, the whole rig maintains exactly as it is. All we're doing is we're merging in downstream and pumping in pan, tilt, zoom, and iris data to lights. If we fail, if we shut down, the system reverts back to normal instantly. I think it's got like a 10 millisecond lag on reverting back at the moment. So the only thing, if we stop working, the only thing you lose is the lights following the person.
Precision, accurateness.
You go
I don't know if we've done this already. So many demos. We can actually get a precision of about 1 millimeter of accuracy now with our cameras. So last night when we were in the Nights of Illumination Awards, we were down to about, I guess, like 1 or 2 millimeters of accuracy over that entire stage. We had 4 cameras in the front, 2 on the sides. We could have even had more precision and better coverage if we had a couple along the back as well, but that wasn't needed for that particular show. So depending on what your use is, you can get up to that much. In a very, very large arena size, you're looking at around like CBC Studios, that was pretty big. we were at about 1 centimeter to 2 centimeters of accuracy. And for a light beam, that's probably pretty good, because now we're just at getting the lights to move as fast as we're sending them the data is the next kind of step. And we already have some ideas in motion for that. Again, like some of those prediction algorithms, if the light's going to lag 100 milliseconds between when I give it the data, we should be looking 100 milliseconds ahead based on what the user's doing. And we've already proved that, I think, at ProLight last year, just by some of our prototypes that we're looking at. So now it's just we have to inject it into the new GUI to make it accessible.
So how terrible is it? How quickly it be set up from the start and then re-implemented into different venues?
Setup is about an hour. Assuming you have all your equipment on site, setup is about an hour. With the KOI stuff, we actually ran into some issues where they forgot half of our stuff here, so we're just waiting for shipments. But all you have to do is hang the cameras on the truss, run one Ethernet cable, Cat6, from the camera down to a hub. Your cameras are ready to go, you aim them. It takes 5 minutes to calibrate the cameras, because do we have the calibration wand here, or is it still at?
No, it's still at
it's
KOI.
Still at KOI. But you would calibrate, it takes about 5 minutes. And then the lights themselves, per follow spot, it's about another 5 minutes just to make sure we get exactly the position of the follow spot. So I can show you on our GUI the fixture calibration. If I click on one of our Sharpies, in our WYSIWYG plots, we pre-queued, we said basically it's around 3.6 meters, but when we actually calibrated, it said it's about 3.65 meters off the ground. So we have that level of precision when we're calibrating, and literally it's about 5 minutes per light, and it'll say you are oriented at half a degree more this way, half a degree more. So if your stagehands up there and they get knocked, they get bumped, you just recalibrate, away you go, and you still have that level of precision.
So the accuracy of where the lights are hung, where the cameras are hung.
It's very tolerant, yeah.
Yeah.
I can help you a little bit. We went into CBC's biggest studios in Canada, 14,000 square feet, basically 120 by 110 feet long, 65 feet high. We went in with road case and we hung 8 cameras. We calibrated the cameras, focused the cameras, calibrated the moving lights, and had tracking up in an hour. That was it.
Do you have the ability to put an offset in? Because at the moment, if you're going to wear a belt pack here, you're not going to want to light your button on.
The LED is where the tracking's looking for, and yes, we can put offsets in. And we've also got IMUs running inside of the beacons, so you can get 4 revolutions, and also you're going to get occlusion coverage. So if you cover up the LED, that part we can't show you yet, it will continue to track. And we're actually at 5 seconds of continued tracking with our tests at the moment. So we've thought all this one through, and we've been steadily working it into the systems.
And we also have 2 user-definable buttons on here. So if you're running some smaller shows and you want the actor to be able to control some cues on the console, they can press a button and we can send up a DMX command up the pipe to the Grand MA or to whatever your favorite console happens to be.
Actually, the buttons are there so that you can talk to anybody else that's connected into the system. So you can fire lighting cues, you can fire sound clips, you can fire special effects if you want. We're putting a lot of control in somebody's hands who's walking across the stage.
Is the system vulnerable to any of the kind of interferences that you might typically find in a venue?
RF interferences?
RF or...
We're running a 2.4 gigahertz system at the moment,
Right.
and we've been in and out. Well, we're here at this trade show.
Yeah.
We've had a few problems, but we've got around them. We've done a whole bunch of things, but to be honest, no, it's working well. But I do see channel hopping and frequency spread coming soon.
Are you using off-the-shelf access point or Wi-Fi?
No, we've built all our own everything.
So you said you go from the camera to the hub,
Yeah.
right? And then the hub is wireless to the processor?
No.
So what we have set up is we have pretty much a couple different types of networks. We have the beacon network, which does the radio frequency communication between the beacon and the server. So this network is designed for syncing, because we basically have unique codes for every single beacon. So they're pulsing at a very high frequency. And this is so we can filter out all the background infrared noise, we can filter out all of that other stuff. And we get the advantage of knowing this is Justin, this is Gil, or this is my elbow or hand. We get that ID as well. So all of that's controlled with our beacon radio network, and that was custom designed. Once that gets onto the PC, we have a wireless access point in 802, or I guess the 5 gigahertz one as well, depending on, it's just a general off-the-shelf wireless access point. So you can remote into our system for calibration purposes. So we were actually at KOI with our tablets, up in the rafters, aiming cameras, down on the ground, calibrating lights from a tablet PC.
Again, Blacktrax adopts the same philosophy. It's all touch screen, it's all portable device deliverable. And if you stand behind a camera and you try and focus it, you don't know what you're doing.
Yeah.
So you take up any portable device, even your iPhone, and you press a button on the side of that camera, and the image of what that camera is seeing will turn to grayscale, put crosshairs in it, and allow you to look at this and go, oh, that's where it needs to be focused.
Yeah.
And you do that, lock it off, and you're set.
Yeah. And again, the focus is very tolerant. If you're off by a little bit, we just calculate that offset. We calculate that position. So it doesn't have to be perfect.
How many beacons can you use at the same time?
Okay, you can run 196 unique identities on the system. But what we're doing is we're narrowing it down because today we're actually delivering DMX out back. We don't want to actually do that in the future. So you can run 12 beacons at any one time, and you can run 48 moving lights at any one time. But to help you get more out of it, we've built something called chapters. And a chapter is like a queue and a patch. It's a relationship. You can have as many chapters as you want, and in every chapter that you have, you can do a maximum of 12 beacons at 48 moving lights.
And it can be different 48 moving lights, they don't have to be the same.
And the chapters are triggered by any DMX channel you want to assign it. So the lighting console can trigger chapters in their queues back to us.
So they
the
run
media server can do the same.
So they would run like a crossfade from me into chapter 2, which could be somewhere else, and then back to me. And then the console themselves can run that like automatically through their queue as just a DMX channel into us.
And is this an output information as well for like audio tracking or for?
Yes, it does. Yeah, definitely.
Yeah, we're working with.
We already work with Timax, we already work with Sonic Emotions, we're already connected into their systems, but we're building a better, very efficient protocol that's going to be generic, and that's what we're going to squirt down to them. It's a 6 degrees of freedom protocol. Just think this one through for a minute. It's got 6 bits of information in it. It's got XYZ, yard, pitch and roll, a unique ID, and it's always referenced to a 000 origin.
So this way, if you have your 3D audio and the person's facing this way, you'll get more output from the speakers behind you. If the person turns, so you have the gyroscopes and face this way, you get more output from the speakers.
What about automated pan tilt zoom video cameras? Is there an
That's the same
interface?
protocol. We're actually working with some of the big players right now.
Stage automation systems and so forth.
Well, we can already listen to the automation systems. We already communicate. WYSIWYG's been doing that for years, so that's not a problem. But we are talking to Sony and the guys about driving robotic cameras, and they all want it.
The next thing.
And they want the ability to pull focus, and we can give them that. We can do all of that stuff. And even Google wants to put this in 5 of their video conferencing centers.
Yeah, our system's basically ready to go. Now we just have to work with them to integrate it with their hardware.
And there's another thing to talk about while we're here, and it's we don't actually want to generate DMX. We don't want to do what all the consoles do already because they're good at it. We just want to squirt that XYZ information right into the consoles. We've got 6 manufacturers in this room today all working on XYZ engines in their consoles. So we can just pump that information in and let them run with it. And when they get that in their console, and Flying Pig came up with this many, many years ago, the things that you can do with moving lights that you could never do before are going to be incredible. And all we're going to do is be an additive incentive into them to give them real-time information.
Yeah. So at the moment we support the downstream DMX merging as for any type of console that's out there today. And then we also support the 6 degree of freedom protocol for some of the higher end consoles that want that information to be able to do some more intelligent things with it.